Welcome back to part 2 of the day 1 lesson on the Randomizer project, where we discuss interfaces, classes, and objects. A quick review of the content from the previous lesson. We created an interface called Randomizer. An interface is a contract that lists the methods that a class must have if it is going to be said to implement that interface. We'll get to what that means in much more detail very shortly. So let's quickly review our randomizer class. Our randomizer class has a method that would return the possible number of outcomes that there could be for the particular type of randomizer that we're creating. So in the next step, when we create a coin, that coin can have two possible outcomes, either heads or tails. Of course, a six-sided die would have six possible outcomes, and a deck of cards traditionally has 52 cards and therefore 52 outcomes. Then we had our getCurrentValue method, and this returns the current value of our randomizer object as a number. Now, does a number make sense when we're talking about a coin that could be heads or tails? It really doesn't, but we apply arbitrary numbers to represent each value, and we do that because we're programmers and numbers are easier to work with than other values. So we'll traditionally apply some kind of numeric value to all of our randomizers. Which leads us to our third method, which is the getCurrentFace method. And in this case, we're going to get a result that might not be numeric. For example, in the case of a coin, we would get heads or tails. In the case of a die, of course, we would still get a numeric value, but represented as a coin. As a number. And then, of course, we would have the example of a card, which would have a string saying something like ace of clubs, or two of diamonds, or queen of hearts. And that brings us to our final method, which falls into the category of a setter. A setter, or a mutator, changes the state of an object, which means that, in this case, it doesn't have a return value. Instead, what it is a command that we issue to our object to randomize itself. In the case of a coin, that would mean flipping the coin. In the case of a die, that would mean rolling it. If we were creating some kind of spinner like a roulette wheel, we would spin the wheel. In the case of a card, we would actually draw a card from the deck, possibly shuffling the deck first, depending upon how we chose to make our deck of cards work. Okay, well, let's get to creating our first actual randomizer object or class. So we'll go to New, Class. We'll call our first class a coin, the simplest form of randomizer. And then we're going to create our java.comment, which will describe a coin. So this will be a coin class that is a random that has a random facing of heads or tails, where tails will be equal to 0 and heads will be 1. And of course, then we'll add our own name. And today will be the 10th of February, which we will make our version number. February 10th, 2015. Okay, now what we have here is a public class. A class is how we create objects. A class is a blueprint for an object. It is not an object itself. And the class takes the place of the type in things that we've done up to this point. We've seen objects in the form of strings. We're now sort of making our own thing, and we're calling it a coin. Now, in our case, we're going to add one other very important keyword, which is that our coin is going to implement the randomizer interface. And because, it implements randomizer the randomizer interface, and because it does, we're going to immediately see that we get this error which is telling us that we have to implement the inherited abstract method randomize. What does that mean? Why is it abstract, and why do we have to implement it? Well, if we switch back to our randomizer class, we can see that, oddly, after each of our methods, there was no code. We've always had curly braces after a method, but in the case of an interface, there's no code, just a semicolon, because that represents the end of our declaration. There's no code involved. Well, now, because we're actually creating a randomizer, not just the abstract idea of a randomizer, we actually have to have code for all of these methods. In other words, by making ourselves a randomizer, we've agreed that we're going to have a getPossibleOutcomes method. But in this case, we must have actual code now, so we're going to change those semicolons to curly braces. So notice I'm selecting the semicolon, replacing it with curly braces, and I'm doing that for each of the methods that was listed in our randomizer interface. And then, of course, we have to write the actual code that goes with these. So, our last one here is our actual randomize method. And now we've got our curly braces for all of our methods. So, are there any of these methods that we already know what to do? Well, it's a coin. How many possible outcomes can it have? A coin can only be heads or tails. Therefore, we are simply going to return 2, the count of possible outcomes. Outcomes are either heads or tails. Therefore, there are 2 of them. Okay, well, that was easy. How about getting the current value? And remember, this is going to be a numeric value. Well, before we can get the current value, we would actually have to know what that value is, and that introduces the problem of, well, where does that value come from, and how do we store it? So first, we store it in something new called an instance variable. An instance variable is a variable that has a scope that is the entire class, which means it's declared outside a method, so it's different than a local variable. That means we can use this variable in all of our methods. So we're going to declare a variable to keep track of whether or not heads is currently showing. So that is going to be, it's also going to use a new keyword, which is private. This variable exists just for the internal use of our coin. No one outside the coin is allowed access to this information, and therefore it is marked private. In the AP subset, all instance variables are always private. And then we're going to make it a Boolean variable, and we're going to call it isHeads, which tells us whether or not heads is currently showing. But notice that we didn't give it a value, because there's a special type of method called a constructor whose job it is to initialize all variables and get your object ready to use. What does a constructor look like? Well, a constructor always has, first of all, it's always public, so we add that keyword, and it always has the same name as the class itself. A constructor always is public and shares the name of the class. It also does not have a return type. This is very important. Constructors are unique because they lack a return type, and that's because what actually gets returned from the constructor is the object itself. We're making a new coin, so we've actually got a coin that we're ready to use after the constructor has been called. So, what is the job of the constructor? Well, generally speaking, its job is to initialize all of the instance variables with reasonable values. In the case of a coin, we want it to start off with a random value, so we're going to create a random number, And remember that the math.random class returns a value between 0 and 1 and less than 1. So we're going to say if that number is less than 0.5, then we want isHeads to be equal to true. And if it's not less than 5, then we want isHeads to be equal to false. Well, this raises a question. Here we're assigning a random value to isHeads, but isn't that actually the job of the randomize method? So let's start by moving this code down to the randomize method, which is where it really belongs, and then call the randomize method. Okay. Now, the next question we have to ask ourselves is how much of this code is actually necessary? Well, we use math.random, or rather we use R here only once. And if I create a variable and I only use it once, I don't usually need to actually create the variable. So here I'm going to replace R with the value that we created. And then we have to analyze this. If math.random is less than 0.5, this expression is true half the time. When it's true, what value do we assign to isHeads? True. And when it's false, we assign what value? False. Therefore, we could much more easily just say isHeads is equal to math.random is less than 0.5. And that shortens our code considerably. Okay, so far we've written a constructor method, and this type of constructor that has no parameters is referred to as a default constructor. Okay, it's a default constructor because there are no parameters. All right, now we get to our current value. And we said that if it's heads, we're going to return 1. So we're going to write a simple if statement that says if isHeads equals true, return 1. Well, is it ever necessary to compare a variable to true? No, it is not. So we could simply simplify that out of existence. And then what do we do if it's not heads? Well, we simply return 0. And the same can be true for the face. We're going to say if isHeads, only in this case we're going to return the string heads. And if it's not heads, we're going to simply return tails. And now we have the complete code for a coin class. In the next lesson, we'll learn how to use that class in our actual program.